This is for metal and hydrochloric acid. There's a lot going on for the calculations for this particular lab. So I'm going to skip through some of these, the background information, the intro. You can read all that. Here, we did talk about balancing equations in Unit 4, so this will be part of what we learned in Unit 4. Balancing equations, though, is still a little bit different because we didn't teach you how to do ratios or fractions using balancing equations. But this is a balanced equation: 3 moles hydrochloric acid, 3 halves H2. And then we see some balanced equations down here as well. And we can see that the ratio of metal to the ratio of hydrogen gas is a 1-to-1 ratio here. Here, it's a 1-to-half ratio. Here, it's a 1-to-3 halves ratio. So here, they give you a practice question. And what's the number of mole equivalents of hydrogen gas produced by the reaction of 1 mole equivalent of magnesium with sulfuric acid? And this would be our reaction here. So it's a single replacement reaction. Magnesium plus sulfuric acid, we get magnesium sulfate plus some hydrogen gas. But we can see here, we're looking at the mole equivalents of hydrogen gas to magnesium, and this is 1 mole to 1 mole. So the mole equivalent is simply just 1. Uh, since we're going to be using this pressure vessel, also the information we learned in Unit 4 is going to be regarding the ideal gas law, PV equals nRT. I've provided you here so you don't have to look in your textbook. The R constant, 0.08206 liter atmospheres per mole Kelvin. But what we didn't talk about was water pressure, the vapor pressure of water. So um, at 20 degrees Celsius, the vapor pressure of water is equal to 20 torr. And you should have a conversion for atmospheres to torr to atmospheres. So to convert torr to atmospheres, you're simply just going to divide that by 760. Let me scoot this temperature one over a little bit. So to calculate atmospheres, if we have a pressure in torr, which you can see the vessel gives us in torr, if we want to convert that value into atmospheres, it's divided by 760. And we're going to be working with some temperatures as well. So the temperature we're going to need to convert is the 22 degrees Celsius into Kelvin. And here's the conversion for that. So 273.15 plus the degrees Celsius gives us our value in Kelvin. So just to start this off a little bit, again, I'm not going to go through every single step here, but just kind of an overview. So let's put the wayboat in there. We're going to tear that out, close this up, tear it, and we're going to put some zinc in here. Yeah. How much do we need here? It's asking us in 2 grams. So I'm just going to tap this a couple times. And again, I'm going to put my value in here and, oh, start that up. There, 1 gram, 2 grams. And I will hit record. So now my value of zinc is recorded there. We'll get rid of the scupula, so just like it says here, and load the zinc into the pressure vessel. So we're just going to put it over here. It's highlighted blue. It dumps it in there, and we can go ahead and get rid of that as well. Now open the vacuum trap by clicking vacuum here. So here, we're just going to click this button right here, and you're going to see this drop to around 3 torr. Once it's down to 3 torr and it's stabilized, I'm probably gonna pause the video, let it get down there. I'm not quite sure. Oh, it looks like it's going. I think the next stage of it, I'm probably gonna pause the video and then restart the video once the reaction is taking place. And you'll notice there's not even anything you can do here. The only option you have is to clean, like the record and the vacuum button are just in red. So there's really nothing else you can do here. But once this is prepared, once this is stable, you'll see that 3.2 torr. We're going to take one of these here. Oh, wait, actually, we need the initial pressure. Our initial pressure, all right, still not stabilized. Once it's stabilized here, this will turn blue and I'll be able to inject that hydrochloric acid into there. You'll see that it's stabilized here now. And now that I hover the acid or the hydrochloric acid over it, it turns blue. So we're just gonna now just go ahead and let it inject. There's nothing I need to do. And you'll see the pressure changing. So this may take a few minutes. So again, I'm just gonna pause it and then resume once this has completed the reaction. But again, see like there's nothing you can even push here. These will turn white and they'll be clickable once the reaction is over. So here, you can actually just go ahead and place that back down here, but you'll see now that the record button is available. Just be patient, let the reaction take place. Could take 3 minutes, could take 5 minutes, could take 10 minutes depending on your computer. But just go ahead and let that reaction take place. I'm gonna put my cursor in here. I'm gonna record this final pressure, and then we can move on. We do have to clean this, so then we just hit the clean button. It's cleaning here. And now that everything's grayed out, it's ready. So you guys are going to do this, but you remember the process that you did here because you're going to repeat it for the unknowns. You'll take the mass of the unknown, pressure of the unknown for both 1 and 2. And we finally get to some calculation. All right. So I do have a kind of a cheat sheet over here that you guys can refer to. Um, write these notes down, save them for later. We need to calculate the moles of zinc. So in the lecture in the unit, we talked about converting moles to grams, grams to moles. So also have a periodic table available, but I have provided you here the molar mass of zinc. It's 65.39 grams per mole, or we could write it as moles per gram. So in order to calculate the number of moles, we know what the mass of zinc is. That's on our data sheet here, right? So we have the mass in grams. If we multiply it by the reciprocal value of the molar mass over here, that will calculate our moles of zinc. And then we need to do some stoichiometry. Now that we have moles of zinc, right, we could use the molar ratio in this reaction here, where we see 1 mole of zinc is equal to 1 mole of uh, hydrogen gas, right? So we could use this ratio here. Whatever the answer is here, we're going to multiply it by 1 mole of H2 over a mole of zinc, and that's going to give us how many moles of hydrogen gas that we have there. Now, something we don't talk about in the lecture or the units is we have to, because of the water itself creates pressure, some vapor pressure. We have to make a correction for that. So we're assuming it's at 22 degrees Celsius, which gives us a pressure of 20 torr that we have to correct for. So we're going to take the pressure of our observation, which was 1160.7. So we take 1160.7 and we simply just subtract 20 from that. So we got 1140. Our corrected pressure would be 1140.7 torr. And this is where we're going to use PV, our ideal gas law, PV equals nRT. If we know what the pressure is, so the volume that we're calculating is the volume of hydrogen gas, the volume of hydrogen gas in this vessel, right? So we have the corrected pressure, right? Which was what we just calculated, 1140. We know what the number of moles is because we calculated the moles of H2 gas already. We know what the R constant because it's right here, and we're assuming a temperature of 22 degrees Celsius, which we're going to convert to Kelvin. So we rearrange this formula to calculate for volume. Volume is equal to the number of moles times the rate constant times the temperature in Kelvin over the pressure in atmospheres. 1140.7. Convert this to atmospheres. And that conversion is right up here. And that will calculate the volume of H2. And you're going to repeat the same calculations, right? You have a pressure for torr. You're going to make the correction there the same way by subtracting 20, subtracting 20. You'll calculate the moles of the same way because you do have the mass of the unknown, right? So by having the mass of the unknown, you calculate the moles of H2 gas the same way there. And now for this page here, the grams of the unknown, grams of moles of H2. Because we're looking at the reaction as a one-to-one ratio, we could just use the mass of the unknown, right? So for this calculation here, you're going to take the mass of the unknown and you're going to divide that mass by the moles of H2. And that will give you the grams per mole, the ratio there of hydrogen gas. So not a horrible calculation to make there. And you'll repeat that process again for the other unknown there. Um, this one here takes a little bit of understanding because we do have to write a reaction, which I've given to you here. So lanthanum is a metal, and we're going to add some hydrochloric acid to that. And we get lanthanum chloride, plus we get 3 halves of hydrogen gas. So um, in order to calculate this, we do need the molar mass of lanthanum. So the periodic table will show you 138.9 grams per mole. But the mole ratio here is different. The mole is it's not a one-to-one ratio. It's 1 mole of lanthanum over 3/2 moles of hydrogen gas. So 1 mole of that over 3/2 moles this. This is our calculation. 1 divided by 3/2 is equal to 2/3. Let me highlight that, right? So we're going to take the mass of this and we're simply going to multiply it by 2/3. Right? Comes out to 92.6, 92.6. And the other reactions are here, right? So I've done the next reaction for you, but manganese and lead are going to be the same as this reaction here. You'll see it's a 1-to-1 ratio. 1 mole of barium, 1 mole of hydrogen gas. 1 mole of manganese, 1 mole of hydrogen gas. 1 mole of lead, 1 mole of hydrogen gas. And since it's a 1-to-1 ratio, well, whatever the mass of barium is, well, that's going to be the number of grams per mole or produced here, right? So we just need to put the molar mass of this, the molar mass of magnesium, and we're coming out with all these molar masses. and you'll put those answers there. But again, for the previous ones, I'm going to show you this one time. So for this one, this is the only one where you need to take the molar mass and multiply it by 2/3. These here, we just need to know what that molar mass of each one of those metals are. Once you do that, you can then determine what your unknowns are. So you're going to have four masses there. I'm sorry, four, grams, gram per moles, and you'll be able to determine which of those unknowns were. So they should match. Unknown one should match one of these, as well as unknown two should also match one of those metals there. So here's our reaction here. Single replacement reaction, zinc plus 2 moles hydrochloric acid, we get zinc chloride plus some hydrogen gas. And you'll see 1:1 ratio there. So it's telling us that we have 1 gram of zinc. So we do have to have a calculation um, where we convert moles to grams, grams to moles. If we have the grams, then you can simply just calculate the number of moles by using the molar mass there. But here, what's not a 1:1 ratio is the moles of hydrochloric acid. It's 2 moles of hydrochloric acid. So our ratio is 1 mole of zinc is equal to 2 moles, excuse me, hydrochloric acid. So 1 mole of zinc, 2 moles of hydrochloric acid. So this is the molar ratio. Once we determine how many moles of zinc are, this is the molar ratio that we're going to multiply by to get and cancel out those units there to get the number of moles of hydrochloric acid, which is asking for in this problem or this section right here. Now, just so you know, and again, we don't really talk about this in the lecture, but the hydrochloric acid was added in excess, right? And the reason that we added in excess was to make sure that all of the metal in this pressure vessel reacts, right? We just want to ensure that it all reacts, that we get our correct pressure, and we can't get that until all of it reacts. So it's essential that there be hydrochloric acid left over after the reaction runs to completion, so all the metal is consumed. Yes, no. So we don't need an exact amount. We just need to make sure that we have more than enough uh, hydrochloric acid so that excess is added. So knowing the exact amount isn't really necessary. And yes, the data will still be usable. To justify the calculation of amount of acid available shows that excess acid will consume all of the metal. You should have observed that in each reaction, the pressures increased rapidly, reaching a maximum, and then it decreased with a steady value. Uh, Back to room temperature. So a different possible explanation would be that the vessel leaks and the pressure decreases in the gas. So they're saying maybe it leaked. Maybe that's why the pressure went down, not because it was consumed, but maybe because there was a leak. In order to kind of, fix that, we could change the amount of zinc so that less than 1 atmosphere of pressure is formed, and there will be no pressure drop due to the leaking when the pressure remains below 1 atmosphere. And what if it was a different temperature? What if it was 30 degrees Celsius? Well, the thing we need to do is we would just use the final temperature of 30 degrees Celsius to make that correction. And that'll finish off this lab here.